Hey guys, so in this next lesson I want to start out by looking actually back at the last example from the last video. And so if you take a look at your notes and just flip back, look at example 9 from 3.9 day 1, you're going to see this example right here, 6 plus 3i times the quantity 6 minus 3i. And if you remember, when we were multiplying this out, we multiplied 6 times 6 to get 36. 6 times negative 3i to get negative 18i, 3i times 6 to get positive 18i, and then we got a negative 9i squared here. And then those middle terms cancel each other out. Okay, so we ended up getting, okay, after doing a little bit of simplifying, replacing I squared with negative 1, just the answer 45. Okay, well, I told you at the end of that video that sometimes when you multiply two complex numbers together, you get a real number, as we did in example 9. Okay, and the reason being is because these two complex numbers in example 9, okay, the 6 plus 3i and the 6 minus 3i, are what we call complex conjugates. Okay, those numbers are called complex conjugates, and complex conjugates are defined as two complex numbers of this form, a plus b times I and a minus b times I. So whenever you have two complex numbers that are conjugates of each other, the only difference is the sign on the imaginary part. The important thing to remember about complex conjugates is that they always come in pairs. Okay, they always come in pairs. That's something that's going to come up a little bit more in our study of Algebra 2. So today we're going to look at how to divide complex numbers, and in order to simplify complex numbers that are being divided, we need to use this concept of a complex conjugate. Okay, so moving down to the next part of your notes. In order to divide complex numbers, okay, you have to remember a really important rule, and that is we do not leave any imaginary numbers in the denominator of a fraction. Okay, I don't know why that's a rule. I just know that is a rule in mathematics. To simplify complex numbers with division, you do not leave complex numbers in the denominator of a fraction. And so in order to get rid of imaginary numbers in the denominator, we're going to do this process here. Okay, that process is we're going to multiply both the numerator and the denominator of your fraction by the complex conjugate of the denominator. So to get rid of imaginary numbers in your denominator, you take the complex conjugate of the denominator and you multiply both the top and bottom by that conjugate. So let me show you how that works. I just got two examples here in the video today, and then we'll get a lot of practice in class for this as well. Number one, you have the number 9 plus 12i all divided by 3i. And so our job is basically to get rid of this I in the bottom, okay, because we don't want an imaginary number in our denominator. So the way we're going to do that is we're going to think, what is the complex conjugate of 3i? By definition, a complex conjugate, if you look back up at the top of your paper, is a number where the imaginary part of your complex number just has the opposite sign. Okay, so in this one here, we have 3i, okay, which you could also say is the same as 0 plus 3i. So its complex conjugate is going to be 0 minus 3i. The only thing we're doing is we're changing the sign on the imaginary part. So what I'm going to do for number 1 here is I'm going to multiply the denominator by negative 3i, and whatever I multiply the denominator by, to keep the fraction the same, I also have to multiply the numerator by that as well, negative 3i. It's kind of like when you're taking the number 4/5 and you're trying to make the denominator, let's say, a 15. You have to multiply the bottom by 3 and also the top by 3. Sort of the same concept there. Okay, whatever you do to the bottom, you must also do to the top. Okay, so now, to simplify this, let's go ahead and do the bottom part first. The bottom, again, the reason we're doing this is because a complex conjugate, or a complex number times its conjugate, will always give you a real number. 3i times negative 3i gives us negative 9i squared, and negative 9i squared is going to be equivalent to negative 9 times negative 1, or just positive 9. Okay, so anytime you take a number times its complex conjugate, you're always going to end up with just a real number, okay, because you're always going to have this I squared here, and that's going to become just a -1. So at the end, we get a +9 on the bottom. Now let's go back and let's do our numerator. So for the numerator, we just need to distribute here. This is the quantity, 9 plus 12i. We're taking it times -3i. So I'm going to distribute my -3i here. 9 times -3i will give me -27i. And then -3i times 12i is going to give me -36i squared. Okay, so now I need to do the same thing in the numerator. I'm going to keep my -27i, but I'm going to change this I squared here to a -1. So this becomes -36 times -1. And so now I get a +36 over here. I'm going to write that first since that's my real part. +36 minus 27i. Okay? From here, there's one more thing I can actually do, and this is going to be similar to what you do in quadratic formula anytime you have those square root answers. We're going to look at the whole numbers, okay, in our fraction here, and if this number, and this number, all three, okay, are divisible by the same number, which they are, they're all divisible by 9, you can go ahead and you can reduce this further, but it has to be all three of these numbers here. So what I'm going to do is I'm going to divide 9 by 9, which is 1, 36 by 9, which is 4, and 27 by 9, which is 3, and this whole answer is going to simplify to 4 minus 3i all over 1, or just 4 minus 3i. So that would be my answer. Okay, let's try this again for number 2, and then again, like I said, you will get a lot more practice of problems like this in class as well. So number 2, we have the quantity 5 plus 3i divided by the quantity 1 minus 2i. And to start this process, I'm going to multiply the top and bottom by the complex conjugate of 1 minus 2i. Again, the conjugate means that you take the opposite sign of the imaginary part, but you don't do anything to the real part. So this +1 here, in the complex conjugate, it's going to stay a +1. What I'm going to do is I'm going to take the opposite sign of this -2i, and so I'm going to multiply the bottom by 1 plus 2i. And again, that's the same thing I multiply the top by, 1 plus 2i. Okay, so now let's go ahead and check out the bottom and see what we get. On the bottom, I'm going to be distributing, okay? This is the quantity 1 minus 2i times the quantity 1 plus 2i. I'm going to show this step up here just to save myself a little bit of room, okay? So we have 1 minus 2i times the quantity 1 plus 2i. So 1 times 1 is 1. 1 plus 2i is positive 2i. Negative 2i times 1 is negative 2i. And negative 2i times 2i is negative 4i squared. Okay? You're going to notice again that these two middle terms, 2i and negative 2i, cancel each other out, just like they did in example 9, okay, on the notes we took yesterday. And again, there's a reason for that. Anytime you multiply a complex number by its conjugate, that's always going to happen because of these opposite signs you have here, this negative here and this positive here. So really, okay, you can do a shortcut. Anytime you're multiplying a complex number times its conjugate, the only things you really have to multiply are the first terms, which are the 1 and the 1, and the last terms, which are a negative 2i and a plus 2i. Those middle terms, the outers and the inners, are always going to cancel each other out. So all we get for this is 1 minus 4i squared, which is just 1 minus 4 times negative 1. Okay, and then 1 minus 4 times negative 1 would be the same thing as 1 plus 4, or just the number 5. So when all is said and done, 1 minus 2i times the quantity 1 plus 2i, your denominator, becomes just the number 5. Okay, now I'm going to go ahead and I'm going to multiply my numerator out. And to multiply your numerator, you're going to have to do FOIL like normal, because again, these aren't conjugates of each other. So I've got 5 plus 3i times the quantity 1 plus 2i. Let's go ahead and multiply that out like normal. 5 times 1 is 5. 5 times 2i is 10i. 3i times 1 is 3i. 3i times 2i squared is 6i squared. Okay, and so now we're going to go ahead and simplify up on that numerator. Again, the denominator is just 5. Up in the numerator, I've got my 5, and then I can go ahead and combine my like terms in the middle. I have a plus 10i and a plus 3i, and that becomes positive 13i. And then I have this plus 6i squared, which just becomes plus 6 times negative 1, which is just a minus 6. So now we have 5 plus 13i minus 6, all divided by 5. Okay, 5 minus 6 is negative 1, so this becomes negative 1 plus 13i, all divided by 5. And unlike the last problem, we can't reduce anything. Okay, negative 1, 13, and 5. Can't do any kind of canceling there. So this right here would be my final answer. Okay, another way you could write it, and you're going to see this written sometimes in your answer keys, okay, and in math books, is a lot of times they'll split up the real part from the imaginary part and just make this two separate fractions. Okay, so another way to write this is by writing it as negative 1/5 plus 13/5 I. Okay, and these would both be acceptable as your final answers. Okay, as usual, go back through and watch anything that you need to in this video. Shoot me an email with any questions you have right away. That way I can be prepared to answer those the next time I see you. And until then, have a nice day. You're wonderful people. Take care.